Assalamualaikum and salam sejahtera. My name is Nurul faizin. Today I'm going to present my project industrial training during my internship period. I was placed on R&D Center at Top Glove, Kelang. During my internship period, I was given to three main projects, which are to assist and generate the compounding auto preparation system at Factory 39 Dental Dam. Second, to conduct a TiO2 study for chemical cost reduction. And third, to optimize the Cydomer formulation for Factory F39 Dental Dam. For the first project, to generate auto preparation Cydomer tank, as automation nowadays is attributed to higher production rates, increased productivity, short production time, and reduced manpower. Besides, to implement Industrial Revolution 4.0, which helps to reduce the manpower and cost of worker, we suggest to install auto preparation Cydomer tank. Cydomer is a chemical substance that we use to reduce the stickiness issue of the film latex after being heated on the oven. So as the film latex is tend to stick to itself after being heated in the main oven, and currently the Cydomer is filled up using manual method in factory. To overcome this problem statement, we suggest to design a system of Cydomer preparation tank for dental dam at production line 2 and to automate the Cydomer preparation tank. The methodology that we use first is to design the mechanism that we use in auto preparation Cydomer tank. Second, to generate PLC program. And third, selection of component. Fourth, calculation of return of investment of the system. And lastly, to install the system itself. There are two tanks, which are Cydomer tank and compounding tank. For the Cydomer tank, we'll store the pure Cydomer solution, while for the compounding tank, we'll compound the Cydomer from the Cydomer tank and water from the pipe. Then we select the component for the system. The process will start when the switch level sensor detected at the lowest level of water. Then the water will fill into the tank until the second level of switch sensor, and water will stop flow, and Cydomer will start flowing until at the third switch sensor level, and the machine will start compounding the Cydomer. Lastly, the compounded Cydomer will outflow to the leaching tank. And then we design the PLC program for this system. As a conclusion, this project is still in progress and some electric components are still pending for delivery. By the end of this month, the electrical part will be installed. Next, for the project 2, optimization of Cydomer formulation for the alternative at Factory 39 Dental Dam. Cydomer is a chemical substance that we use to prevent stickiness issue after the dental dam is being heated from the oven. The formulation of Cydomer content is very important to generate the best solution to avoid any stickiness issue on the product of dental dam. Besides, to produce high quality of dental dam. The factory of 39 dental dam has issue on stickiness of the latex film. The current formulation of Cydomer is and adequate to solve the stickiness issue of latex film. The objective of this study to find out the best formulation of chemical substance on the cytomer. The method that we use, first we cast the film latex and then compound the new version of cytomer according to the preferred total solid content and immerse the latex film into the solution, the cytomer solution, and then try the film into the oven. After that, we conduct several tests on the cytomer solution and the latex film. After preparation of cytomer and latex film, we conduct several tests on the cytomer solution and latex film. For the cytomer, we used to test the pH value and viscosity value. And for the latex film, we test the water rub test, flaking test, coefficient of friction, blocking test, and powder content. From the result, we could see the pH value of set 1 is slightly higher than set 2 and set 3, while for the viscosity value, set 1 is the highest rather than set 2 and set 3. For the latex film, set 2 is observed with no flow mark rather than set 1 and set 3, they found the flow marks on the latex film. And for the water rub test, is basically we check the adhesive of the latex film. And lastly, for the blocking test, set 2 is fail and set 1 and set 3 pass. Our objective to reduce the tackiness and stickiness issue and perform the better film and smoother film. Set 3 from smoother film compared to set 1 and set 2. In future, cytomer dosage needs to be increased to 5%. For the last project, TiO2 dispersion study for factory 39 dental dam. As the dental dam that we use currently is light blue, require high consumption of TiO2 compared to the other dental dam. Hence, to reduce the TiO2 cost, the consumption of TiO2 needs to be reduced. The objective of this study to reduce the consumption of TiO2 itself and to compare the color concentration after reducing the TiO2. The methodology that we use, compound the natural rubber dental dam, light blue, flowing to the formulation and check the colorimeter test. First and foremost, we compound 4 sets of film latex with following formulation. In this case, all the content of chemical substance are same as well except for these 3 formulation for TiO2, blue pigment and green pigment for each set. The control set is basically the one that we refer to. After that, we conduct the colorimeter test on the film latex. From the data we gain, all the film latex are failed. As a conclusion for this study, the dosage of pigment and TiO2 need to be adjusted. This test will be repeated until we achieve the objective of this study. So that's all for me. Thank you.